Hello, my name is Matthew Yakov, and today we're going to talk about branch high availability and specifically about the active-active topology that we can utilize in the Versa SD-WAN construct. The agenda for today. First, we're going to review how the connectivity is happening without high availability, when we have just a simple branch on one side and another on another side. Then we're going to review a little more complex solution when we actually have high availability configured in our network and how the system establishes tunnels, data path, and the last one, we're going to take a couple of examples how in real life we can implement active-active topology and what to look for. So, external topology without high availability. In this example, we're going to have two sites, site 1 and site 2. We have SD-WAN devices, branch 1 and branch 2. We also have clients that are located behind branch 1 and clients that are behind branch 2, which needs to communicate to each other. And two transports that are available for the branches to reach each other is going to be Internet circuit and MPLS circuit. The very first thing that is going to happen when the branch 1 or branch 2 comes up, boots up, and the first operation that is going to happen, branch 1 and 2, they will reach out to the controller and they will inform controller that they online and they want to communicate with other branches. Branch 1 and branch 2, they do not store information about each other in their configuration. The only configuration that they store is how to reach controller. This is the whole purpose of the SD-WAN, so we don't have to put separately data how to reach to each of the branches. We dynamically receive this from the controller, and the only configuration that we have is how to reach to the controller. So, based on the information received from the controller, branch 1 and branch 2 will try to establish two tunnels between each other. First, unencrypted, and second, encrypted IPsec tunnel. And both of those tunnels will be able to communicate between branch 1 and branch 2 through Internet and MPLS. So they will have two data paths to reach from one to another. Data paths, in this case, will have both source and destination ports as 4790. This will always be the case if the communication is happening one-to-one over the Internet or MPLS. Now let's view this a little deeper. So, to support previously described configuration, system will create two VRFs for Internet transport and MPLS transport. Also, system will create a LAN VRF for our LAN site. And as always in our construct, we're going to have control VR that is used for establishing all SD-WAN tunnels between branches and also for communication to the controller. So when the branch number 1 will be communicating to the controller, the communication will be happening from control VR. So technically control VR is our SD-WAN. When the control VR will establish control tunnel to the controller, he will inform controller that, hi, I'm branch 1 and I have LAN VRF with these networks. And also, if anyone wants to reach me and establish tunnels to me, you can establish data path through Internet, and here is my IP address and my port, and also here is my MPLS reachable via this IP address and this port. Similar information is going to be transmitted by the branch 2. And controller in this case will just reflect this information between branches. So controller will receive message from branch 1 and send it to the branch 2. And the same is going to happen with the message from branch 2 to branch 1. Now, based on the information exchanged between branches, they will establish encrypted and unencrypted tunnels, and those tunnels will be able to use two data paths, one over the Internet and second over the MPLS. Now, where we can actually see information about those IP addresses and ports which are used for communication between branches. For this, we can go to the Versa director. And in this Versa director, I have three sites, site 1, site 2, and site 3. On the site 1, I have two devices in the active-active configuration. On the site 2 and site 3, I have two single branches. So let's see how the communication from branch 2 is happening to the branch 3. We can click on the branch 2, go to the Monitor tab, and in the Services menu in the SD-WAN, we can see transport path between branch 2 and branch 3. So here we see plain text tunnel is available through Internet and MPLS, and encrypted tunnel is available through Internet and MPLS as well. If we want to see IP addresses and ports that are used externally in the data path, we can go to this site, and now let's click on the branch 3 because we want to see from the branch 2 how we're reaching branch 3. So we're clicking on this eye. Let's extend it a little. And here are the IP addresses that are actually used on the underlay to reach other site. So this is the IP address that branch 2 uses to reach branch 3. And here's the port that is used by the branch 2 to reach branch 3. Similarly, we can see the same information from the CLI. So if we're going to go to the branch 2, we can run the command show org Versa SD-WAN detail and branch 3. So from the branch 2, we want to see information how to reach branch 3. And here's the information about the data path, and specifically what are the ports used to reach the other side. Those IP addresses and ports are going to be used by both encrypted and unencrypted tunnels. Now let's go and review the situation with high availability configuration. For this, we're going to need to have two devices on the site 1. So we will have branch 1A and we'll have also branch 1B. They both will be connected on the LAN to the customer PCs, and most probably they're going to run VRP or some routing protocol if there's going to be an additional router on the LAN side. And also, the branches 1A and branch B will have connection to the internet and to the MPLS. Now, it is very important to understand that branch 1A will have only one connection to the internet, but will not have connection to the MPLS, at least not the direct one. And the same is for the branch 1B. You can ask me, then how is branch 1A will reach MPLS network? For this, we have a cross connection between branch 1A and branch 1B. You see the two lines that were just drawn between two branches. Those two lines represent two logical connections between branch 1A and branch 1B. And I'm going to show animation once again. 1 and 2nd. So physical connection, only one, but logical, two of them. One of them is going to be used, one of the logical connections is going to be used by the branch 1A to reach through the MPLS network to the other side, and second will be used by the branch 1B to reach to the internet. As soon as the topology is built, all the branches in the current topology will reach out to the controller and will send information to the controller about their LAN networks, about their WAN networks, and how to reach to each other. So after this information is received by the controller, it gets reflected to all other devices, and branch 2 will try to establish one IPsec tunnel to the branch 1A, and it will use two data paths over the internet and another one over the MPLS. The ports that are going to be used for the data path by the branch 2 are going to be a source UDP port 4790, destination UDP port 4790. But on the MPLS connection, as branch 1A doesn't have direct reachability to the MPLS, it will use different port. So in this case, just for example, I gave the port 10,000, the actual port is randomly assigned. Similarly, two data paths for the encrypted and unencrypted tunnel that will be used to reach from the branch 2 to the branch 1B. We'll have port 4790 when it's the direct connection, but if the connection is through another branch, the port is going to be randomly assigned. Now let's see this in a little more details. Under the hood, branch 1A and branch 1B will have the same number of VRFs as if it was the single branch deployment. Remember on the previous slide I showed you one physical connection and two logical connections between branches in the high available configuration. So the logical connection, first one, is going to be between MPLS VRF on the branch 1A and MPLS VRF on the branch 1B. This one is created for extension of the MPLS VRF from one side to another. And the IP addresses that are going to be assigned by the workflow will always be 172.16.255.1/30 on the A side and 255.2 on the B side. The same is going to be logical connection for extension of the internet network from the branch 1A to the branch 1B. And please note one thing. The IP addresses 172.16.255.1 is going to be on both MPLS VRF and Internet VRF. As they are in a different VRFs, we can have overlapping IP addresses, but those values are hard-coded in workflow. Now, what will branches advertise to the controller? Branch number 2 will advertise the same information as in the previous example. But what will be advertised by the branch 1A and branch 1B? Let's review this from the perspective of the branch 1A. So for this, I'm going to leave only VRFs that are imported for this example. So branch 1A will send the message to the controller that, hey, I'm branch 1A and I have LAN VRF with the network 10.0.0.0/24, and if anyone wants to reach me, I have WAN networks internet, which is reachable via 1234 port 4790, and I also have MPLS network that is reachable via 172.16.255.1 port 4790. By the way, source port will always be 4790 unless you change it in the global configuration. You can ask me, then if branch 1A advertises MPLS network as 172.16.255.1, which is RFC 1918 address space, so it's a private address space that cannot be reached from the internet or MPLS. So how will branch 2 know how to get to this IP address specifically and to this port? For this, we have a special trick. So as soon as the very first packet that is sourced from 172.16.255.1 leaves the box and traverses through the branch 1B, branch 1B will send information to the controller. Hey, I'm branch 1B and I have a certain parameter that is called paired site ID. In this case, it's going to be, for example, site 1. Somebody else, so another branch that is connected to my cross-link connection, just tried to send packet out using source port 4790. I did a net translation and translated it to the 5678 port 10,000. And this translation is going to be permanent. Doesn't matter where this packet is going to be forwarded to which destination. The source port to which I'm going to be translating him will always be 10,000. All this information combined together will be sent to the controller, and controller will send it to the branch 2. So branch 2 will receive something like this. Hey, I'm branch 1A and I have this LAN VRF, and also I have internet transport, which is reachable via 1234 port 4790, and also I have MPLS network that is reachable via either 172.16.255.1 port 4790, or also MPLS link of branch 1A can be reached through the IP address 5678 port 10,000. So in this case, branch 2 will try to establish connection to both 172.16.255.1 and 5678 port 10,000. Whatever connection comes up first, that one is going to be used for communication between branch 2 and branch 1A. And therefore, the data path that is going to be established for our IPsec tunnel, first one is going to go like this, and second is going to go like that. So we have one IPsec tunnel between control VR of branch 2 and control VR of branch 1A, but this IPsec tunnel can traverse either through the internet or through MPLS using data path of internet or MPLS. So where can we see all that information, all those messages about the IP addresses and ports that are being used? For this, first let's see this from the GUI perspective. We're going to go to the Versa director. Here we are in the monitor menu of the branch 2. So in the branch 2, we're going to go to the services, SD-WAN, and here in the site configuration, we're going to see from the perspective of branch 2, how do we connect to the branch 1A? And here is the information. And it shows that for the connection over the internet, we're using the data path IP address 172.16.10.101, but the IP address that is actually being used to reach the branch 1A through the MPLS is going to be 172.16.20.102. And it shows that data path IP, the actual IP address that is used on the underlay. And here's the port that is being used. This is the port that branch 1B advertised to us. And also here's the information that branch 1A advertised about his network. So we can see that branch 1A advertised this IP address for his MPLS network. We see that we have a net translation that is being done by the branch 1B. Here's the port that we're using to reach the actual IP address, and here's the actual IP address that we're using for the data path for reaching from the branch 2 to the branch 1A. Similarly, we can see this information from the CLI. So let's go on the branch 2. And we're going to use command show orgs org Versa SD-WAN details, and we want to see the connection from branch 2 to the branch 1A. Look at the output. First, here we have the information that was advertised by the branch 1A. Branch 1A advertised that it has this IP address on the MPLS network and this IP address on the internet network. But the actual data path communication is happening to these IP addresses and these ports. So we can say that in this view, we have IP address that is advertised by the branch 1A, IP address that is advertised by the branch 1B, and here's what is the actually established communication for the data path between branches. Now let's see important configuration steps that you need to do to configure active-active configuration properly. For this, let's go to the Versa director. So first thing that you would do, you would create template for both branches on the A side and B side. So we're creating template. And here we're specifying that we will create two templates actually, for the A side and for the B side. Also here we can control whether we want to run VRP between them or no. And on the interfaces, you can see that we're specifying on the A side, we will have internet network. On the B side, in here, we'll have only MPLS network. And also port number 2 is going to be used for the cross connect. So one port, one physical, and two logical connections is going to be going through this port. But please note one thing. There is no information about the paired site ID. This is purposely done in this way because these templates, the template for the A side and B, can be utilized by multiple sites, and the site ID on a specific site should be unique. So the site ID is going to be configured on the actual device that we will configure based on the template. And here's the device branch 1A. On the branch 1A, we're going to configure that the paired site ID is going to be site 1. You can use any letters or any digits for paired site ID, but don't forget that it needs to be the same on both A and B side on our branch. So we're specifying site 1 on the branch 1A and also on the branch 1B. We are also specifying site 1 as our paired site ID. Now, what to avoid? First of all, in the Versa construct, you cannot have more than 2 sites with the same site ID. If you will have 3 sites that will have the same paired site ID, it will create unpredictable behavior in your SD-WAN network. So you will see link flaps, you'll have net translation problems, you'll have convergence problems. So always only 2 sites can have the same paired site ID. If you have more than 2, you will have problems. Second, it's actually very convenient to configure your site name in the paired site ID. So for example, if you have office somewhere in the Alaska, you can say that paired site ID is Alaska 1 on both of those branches, which will also help you to identify where this branch belong based on the paired site ID. So this finalizes our video. I hope this was informative for you, and thank you for watching.